Hi friends, this is Naresh. In this class, I am going to explain about centroid of an Z section. This is my 7th class on centroids problems. Here, question is locate the centroid or center of gravity of the given Z section. Here, I am showing 3 different shapes of Z sections. So, I am considering this as 3 problems. In this is first model, this is second model, and this is third model. First of all, you have to know the basics of centroid of an rectangle. This is a rectangle of base B and depth D, where B refers base or length, D refers depth or height. Okay, this is the centroid of a rectangle. It lies at where the diagonals meet together. Okay, this is the centroid. So CZ is the centroid or center of gravity of a rectangle. This is a first model. Look at the centroid or center of gravity of the given Z section. The dimensions are given here. This is the bottom rectangle having 100 mm length and height 20 mm, and height of a rectangle from here to here 80 mm, and the length of the top rectangle 120 mm, and depth 10 mm. So first of all, the given Z section is split up into 3 small rectangles. Like this is the first rectangle. The dimensions are, I treated as section 1, and the dimensions are base B1 equal to 100 mm, and depth or height D1 equal to 20 mm. So these are these dimensions. Now I am considering the second rectangle as section 2. Dimensions are base 2 equal to 20 mm, and height or depth of second rectangle D2 equal to 80 minus 20, that is a 60. So D2 equal to 60 mm from here to here only. Now I am taking the third rectangle as section 3. This is section 3. The dimensions are base B3 equal to 120 and depth D3 equal to 10 mm. This is the base. From here to here 120 mm. From here to here depth D3 equal to 10 mm. Now I am considering the reference axis, x-axis at the bottom edge and y-axis at the left side edge. So this is the origin. In next slide I will explain about location of centroid. Now coming to the areas, A1 is the area of a yellow rectangle or section, first section. A1 equal to base into depth, that is B1 into D1 equal to 100 by 20 equal to 2000 mm square. So B1 D1, so 100 by 20. is the area of this rectangle. Now area of a second rectangle is B2 into D2. So B2 equal 20 and D2 equal 60. So area 2 equal to 20 by 60. So this is the area of a second rectangle. Now I am taking a third rectangle. The area of a third rectangle A3 equal to depth D3 into base B3. So therefore area 3 equal to B3 into D3 equal to 120 by 10 mm. That is equal to 1200 mm square. So these are areas. For total area, capital A equal to A1 plus A2 plus A3. Now I am drawing the reference axis. Okay, now to locate the individual centroids, first of all you have to draw the diagonal lines. So I am drawing the diagonal lines to locate the individual centroids. Here C1 is the centroid of a bottom rectangle at a distance of x1 from y-axis and y1 from x-axis. Here the value of x1 is equal to 100 plus b1 by 2. So x1, the dish from y-axis to C1, the distance between y-axis to C1 is the x1 equal to the gap 100 mm plus base of a rectangle b1 by 2. So half of the base plus gap. So x1 equal to 100 plus b1 by 2. In similar way, y1 equal to half of the height. So therefore y1 equal to d1 by 2. Now I am drawing the diagonals for second rectangle to locate the centroid C2. Now C2 is the centroid of a second rectangle at a distance of x2 from y-axis. That is x2 equal to gap 100 mm plus base 2 by 2. So half of the base plus gap. Now y2 from x-axis. y2 equal to height of a bottom rectangle d1 plus half of the second rectangle. So y2 equal to d1 plus d2 by 2. Now I am drawing the diagonals for third rectangle. Now C3 is the centroid of a third rectangle at a distance of x3 from y-axis and y3 from x-axis. Here x3 equal to base 3 by 2. There is no gap, so I am taking the half of the base. So x3 equal to b3 by 2 and y3 equal to height of a bottom rectangle plus height of a second rectangle plus half of the third rectangle. So d1 plus d2 plus d3 by 2. So these are the values from figure. x1 equal to 100 plus b1 by 2 equal to 150 mm, x2 equal to 100 plus b2 by 2 equal to 110 mm, and x3 equal to b3 by 2 equal to 60 mm, and y1 equal to d1 by 2, that is equal to 10 mm, and y2 equal to d1 plus d2 by 2 equal to 20 plus 30 equal to 50 mm, and y3 equal to d1 plus d2 plus d3 by 2 equal to 20 plus 60 plus 5, 20 plus 60 plus and a half 5, so 85 mm. So y3 equal to 85 mm. Now I am written these values in tabular form. So these are the section numbers, these are the plane names, these are the dimensions for individual rectangles, these are the corresponding areas, and x and y values are the individual centroids. Now from general expression, xc equal to the distance of centroid or center of gravity from y-axis, and yc equal to the distance of centroid or center of gravity from x axis. From general formula, x equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3, and substitute the values, we will get the answer x equal to 114.54 mm. Similarly, yc equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3, and the final answer is yc equal to 41.36 mm. So in next slide I will show the location of centroid of an Z section. Now C1 is the centroid of a bottom rectangle, C2 is the centroid of a vertical rectangle, C3 is the centroid of a top rectangle, where C1, C2, C3 are the individual centroids, but CG, center of gravity, is the centroid of an entire Z section. So CG is the centroid of an entire Z section at a distance of XC. XC equal to 114.54 mm and YC equal to 41.3 mm. So it is the centroid or center of gravity of the Z section. These are the final answers. Now coming to the another model. Same question, look at the centroid or center of gravity of the given Z section, but the difference is rotation of but the main difference is Z section. Now first of all, the given section is split up into three rectangles like this. Bottom rectangle, dimensions base 1 equal to 100 mm and height d1 equal to 20 mm, and second rectangle I am considering as section 2, dimensions are base 2 equal to 20 mm and depth 2 d2 equal to 60 mm from here to here, only from here to here. So therefore d2 equal to 60 mm. Now this is the third section and the dimensions are base 3 b3 equal to 120 mm and depth d3 equal to 10 mm. So these are the dimensions. Now I am considering the reference axis, x-axis at the bottom edge and y-axis at the left side edge. Now O is the origin. Now coming to the areas, area of a first section a1 equal to base into depth, so b1 into d1 equal to 100 by 20. So 100 into 20 equal to 2000 mm square. Now A2 is the area of a second rectangle. A2 equal to B2 into D2. So B2 equal to 20 mm, D2 equal to 60 mm. So area 2 equal to B2 by D2 equal to 20 by 60 equal to 1200 mm square. Now A3 is the area of a third section. D3 equal to 10 mm and B3 equal to 120 mm. So A3 equal to base 3 into D3 equal to 120 by 10 equal to 1200 mm square. Now I am taking the reference axis, x-axis, y-axis and origin. Now I am drawing the diagonal lines to locate the individual centroids. Now C1 is the centroid of a bottom rectangle at a distance of x1 from y-axis. Therefore x1 equal to b1 by 2, and at a distance of y1 from x-axis, that is y1 equal to d1 by 2. Here x1 equal to half of the base and y1 equal to half of the depth. In similar way, I am drawing the diagonal lines for second rectangle to locate the centroid C2. Now C2 is the centroid of a second rectangle at a distance of x2. x2 equal to 80 plus b2 by 2 and y2 equal to d1 plus d2 by 2. Here x2 equal to gap 80 mm plus half of the base. So gap 80 mm plus b2 by 2. So from here to here, x2 equal to from here to here, that is 80 plus b2 by 2. Now y2 equal to from centroid C2 to x-axis. That means y2 equal to height of a bottom rectangle, that is d1 plus half of the second rectangle. So y2 equal to d1 plus d2 by 2. Now I am drawing the diagonals for third rectangle, where C3 is the centroid of a third rectangle at a distance of x3. x3 equal to gap 80 mm plus half of the base, and y3 from x-axis, y3 equal to height of a bottom rectangle plus height of a second rectangle plus half of the third rectangle. So y3 equal to d1 plus d2 plus d3 by 2. Here x3 equal to gap 80 mm plus half of the base, that is 80 plus b3 by 2. From figure, x1 equal to b1 by 2 equal to 50 mm, x2 equal to 80 plus b2 by 2 equal to 90 mm, x3 equal to 80 plus b3 by 2 equal to 140 mm, y1 equal to d1 by 2, that is 10 mm, and y2 equal to d1 plus d2 by 2 equal to 50 mm, and y3 equal to d1 plus d2 plus d3 by 2 equal to 85 mm. So in next slide I will show the centroid formula. These are the dimensions, these are the section numbers, these are the plane names, these are the individual dimensions and their corresponding areas. X and Y are the values of individual centroids. Now from general expression, xc is the distance of centroid from y-axis, yc is the distance of centroid from x-axis, xc equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. Answer is x equal to 85.45 mm. Now from general expression for yc equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3, and answer is yc equal to 41.36 mm. Now C x-axis, y-axis, origin. Now C1 is the centroid of a bottom rectangle, C2 is the centroid of a vertical rectangle, C3 is the centroid of a top rectangle. So where C1, C2, C3 are the individual centroids, but CZ is the centroid of a entire section at a distance of xc equal to 85.45 mm. This is the centroid of a Z section, and xc equal to 85.445 mm from y-axis, and yc equal to 41.36 mm from x-axis. So this is the final position of a centroid, and answers are x equal to 85.45 mm, y equal to 41.36. So this is the final position of a centroid of an Z section. Now coming to the third model, question is same. Now first of all, the given section is split up into 3 rectangles. I am taking the bottom rectangle from here to here only. So therefore the height of a bottom rectangle is 80 mm. So height of a bottom rectangle equal to 80 mm, and the base of a bottom rectangle equal to 20 mm. So b1 equal to 20, d1 equal to 80. These are the dimensions for bottom rectangle. Now I am considering the second rectangle. Now I am considering the second rectangle from here, from this end to this end. So therefore the length of the second rectangle is 80 plus 10. So base 2 equal to 90 mm, 80 plus 10 equal to 90 mm, and height or depth d2 equal to 20 mm. This is d2. Now I am considering the third section from here to here only. Therefore the dimensions are base 3 equal to 10 mm. Now depth d3 equal to 80 mm. So the height of a third rectangle is from here to here is total height 100 mm minus 20 mm. So therefore the height of a third rectangle is 100 minus 20 equal to 80 mm. So d3 equal to 80 mm. So these are the dimensions. Now I am considering the reference axis. X-axis at the bottom edge and y-axis at the left side edge. O is the origin. Now coming to the areas. A1 is the area of a bottom rectangle. So area 1 equal to B1 into D1 equal to 20 by 80. This is the area 1. Similarly area 2 equal to base 2 B2 into depth D2. That is area 2 equal to 90 by 20 mm. That is equal to 1800 mm square. Now A3 is the area of a top rectangle, base 3 equal to 10 mm, and depth D3 equal to 80 mm. So A3 equal to B3 into D3 equal to 800 mm square. Now, now I am considering the reference axis. This is the x-axis, this is y-axis. This is the origin. Now I am drawing the diagonal lines to locate the individual centroids. C1 is the centroid of a bottom rectangle at a distance of x1. x1 equal to gap 70 mm plus base by 2. So from here to here the gap is 70 mm plus base by 2, that is 20 by 2. So 70 plus b1 by 2 is the x1 value. Now y1 equal to height of the rectangle by 2, that is d1 by 2 from x-axis. In similar way, C2 is the centroid of a second rectangle at a distance of x2 from y-axis. x2 equal to base by 2 and y2 equal to d1 plus d2 by 2 from x-axis, where for a second rectangle x2 equal to base by 2 because there is no gap, so x2 equal to half of the base only, so x2 equal to b2 by 2. Now y2 equal to height of the bottom rectangle, that is d1 plus half of the second rectangle, so d1 plus d2 by 2. In similar way, c3 is the centroid of a third rectangle at a distance of x3 from y-axis and y3 from x-axis, where x3 equal to base 3 by 2, that is 10 by 2 equal to 5 mm, and y3 equal to half, y3 equal to height of a bottom rectangle d1 plus height of a second rectangle d2 plus half of the third rectangle d3 by 2. So y3 equal to d1 plus d2 plus d3 by 2. From figure, x1 equal to 80 mm, x2 equal to 45 mm, x3 equal to 5 mm, y1 equal to 40 mm, y2 equal to 90 mm, y3 equal to 140 mm. Now these values are written in tabular form. Similar formula from general expression, x equal to 50.71 mm and yc equal to 80.47 mm. So xc, yc are the coordinates of the centroid. Now I am showing the final position of a centroid, where C1 is the centroid of a bottom rectangle, C2 is the centroid of a horizontal rectangle, C3 is the centroid of a top rectangle, whereas CZ or centroid or center of gravity is the at a distance of xc equal to 50.71 mm and yc equal to 80.47 mm. So CZ is the centroid of an entire section, whereas C1, C2, C3 are the individual centroids. So the final answer is xc equal to 50.71, yc equal to 80.47 mm. So this is the final location of a centroid. This is the final position. Thank you very much.